Okay, bismillahirrahmanirrahim. Assalamualaikum and hi guys. Okay, so today in this video, I will cover chapter 8.2, Asymptotes. Okay, so basically what we are going to do is we are going to find VA, vertical asymptote, and also horizontal asymptote, HA, using the limits. Okay, so basically dua-dua ni korang dah pernah go through dah dekat dalam lecture hari tu, which is VA ni actually infinite limits. Okay, kita dah belajar hari tu, infinite limits, which is case yang mana you get constant, any constant selain daripada 0 and deal over 0. So you have to identify whether your 0 is a positive or negative 0. Okay, using the substitution method, and then the final answer will be either plus or minus infinity. Okay, and then untuk HA pula basically is limits at infinity. Okay, which is korang akan cari limits when x approaching positive or negative infinity, you will get a value. Okay, and value tu actually adalah your HA. Okay, so we go through one by one. We go through vertical asymptotes dulu. So I believe everyone knows what is asymptotes. Okay, vertical asymptote is x equal to something. Let's say x equal to A. And the asymptote means your graph cannot touch the asymptote. Okay, dia tak boleh sentuh. Dia hanya approaching, mendekati. Okay, tak boleh sentuh. Sebab apa? Bila sentuh, your function will be undefined. Okay, so what are the steps to find the vertical asymptotes using limits? So first of all, you have to find the value of A ni dulu. Kena tahu apa value of A ni. So nak tahu value dia senang sahaja. You just gonna find the value that causes the denominator to be 0. Okay, and then bila dah tahu nilai A tu, you just have to find the limit when x approaching from left and also x approaching from right. So if you get positive or a negative infinity, and dekat sini positive or negative infinity, automatic you have already proved that x equal to A is your vertical asymptote. Okay, so kalau korang nampak dekat sini dia all kan, so maksudnya tak kisah. So let's say awak dapat yang ini and ni undefined, ataupun awak dapat yang ini tapi yang ni undefined, it's okay. Either if you have this one or this one, the final answer infinity, then boleh terus conclude that it is vertical asymptote. X equal to A is vertical asymptote. Okay, but you need to show both lah. Jalan kerja mesti tunjuk dua-dua. Okay, so kita go through example terus. So determine the vertical asymptotes of. Okay, ada 3 example. Saya buat satu je sebab lebih kurang je semua. Okay, so kita nak cari vertical asymptote untuk this one. So remember, kita kena cari value of A. Value of A adalah yang causes the denominator to be 0. So dekat sini lah basically. Okay, so kita tahu dekat denominator tu tak boleh equal to 0, right? So x it cannot be negative 2. So this will be your A. Nilai A awak yang awak nak masukkan dekat sini. Okay, alright. So now, as you can see from the notes, kita akan cari approaching from left and approaching from right. Kena buat dua-dua ya guys. Kena buat dua-dua. Wajib kena buat dua-dua. So the first one, we approach negative 2 from left. Okay. And then the function is x plus 3, x plus 2. Okay, saya masukkan negative 2 tambah 3. So sini kosong. Okay, remember. So we have negative 1 over 0. So you have to identify 0 ni adakah 0 yang positif atau negatif. So remember how we solve it in the lecture. Kita case number 9, and then this is your negative 2, and then plus minus with 1, plus minus with 0.1. So here is negative 1.9, here is negative 2.1. Okay, so for this part, untuk this part kita akan masukkan dari kiri. So maksudnya kita akan masukkan x plus 3 over x plus 2, right? So kita akan masukkan dia jadi from left kan? From left, so meaning you need to use this value. Negative 2.1 plus 3. And then yang bawah adalah negative 2.1 plus 2. So yang atas awak dapat positive number 3.1, 0.9 is it? 0.9, 0.9. Yang bawah awak dapat negative 0.1. So you see here it is a negative number. So meaning value dia, 0 dia adalah negative. Okay, this is negative. Okay, so 1 divided by 0 yang negative. So positive bagi dengan negative dapat negative. So negative apa? Negative infinity. Okay, so you do the same untuk from the right. So from the right you're gonna use the function, the value negative 1.9 to substitute into here and here. So I'll just give you the final answer. You will get positive 0, so it will be positive infinity. Okay, so when you already got these two answer, you already show from the left and from the right, so this is the answer. So you can just conclude that your vertical asymptote is x equal to negative 2. Okay, that's how you do it. Okay, so for horizontal asymptotes, so you just need to find the limit when x approaching positive infinity and also negative infinity, so you will get a value. So the value is actually your horizontal asymptote. Okay, the value that you get is your horizontal asymptote. Okay, so again, there is r over here, so meaning that either you get this one or this one, then your y equal to b is still your horizontal asymptote. It doesn't need to prove, it doesn't need to both to be correct. Okay, so we're gonna try the example 2a. Okay, so a, so we have to find the limit x approaching infinity. So we're gonna try approaching positive infinity first. So x over x minus 2. So when you substitute infinity, here will be infinity. At the bottom will also be infinity. So remember, for case that infinity over infinity, you have to find the highest power for denominator, which is in this case x. Okay, and then what you need to do is you have to divide each term with the x. So they become like this. Okay, and then don't forget to simplify. So become 1. Sorry, this is x. 1 minus 2 over x. Okay, so we substitute infinity here, become 1, and this one become 0. So we get 1 minus 0 is become 1. Okay, so you just do the same when x approaching negative infinity. So you can do by your own. So the final answer is also 1. Okay, so 1 here. So you can just conclude that horizontal asymptote is y equal to 1. Okay, that's how you show or find the vertical and horizontal asymptote using limits. Okay, so saya nak remind again that awak kena buat dua side and kena tunjuk both side, dua arah. Okay, tak boleh dalam exam nak buat ni je dah cukup. Okay, nak buat ni je dah cukup, dah proof. Tak boleh, kena tunjuk dua jalan kerja. Okay, same as this one. Walaupun jawapan dia sama 1, kena tunjuk juga dua arah. Okay, alright. Okay guys, so now we are going to answer this question number 3. So we are given a function fx blah 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 blah. So we need to find the domain. Okay, as you know, domain is syarat untuk nilai x. Okay, so in this case, adakah semua nilai x boleh? Adakah dia negative infinity sampai infinity? No. Kenapa? Sebab dia ada denominator dekat sini. So we know that your denominator cannot be 0 kan? Okay, so we know that denominator cannot be 0. So you know that x minus 1, x plus 3 cannot be 0. Okay, so from this you know that your x minus 1 cannot be 0, so your x cannot be 1. Same as x plus 3 cannot be 0, so meaning your x cannot be negative 3. Okay, so basically this is your asymptotes, vertical asymptotes. So you have two values that you cannot include in this function. Okay, so when you already have these two values, you know that your domain gonna be all numbers except 1 and negative 3. So how do you write the final answer? So your domain is actually, we start from negative infinity until negative 3. We need to stop here and we need to use open bracket because we cannot include negative 3 in our function. And then we continue again with union, negative 3 until 1, and we stop again, we continue 1 until infinity. So this is your domain. So your domain can take any value of x except 1 and negative 3. Okay, for B, they want us to find the x-intercept and y-intercept of f. Okay, so for B, we need to find the intercept. So for x-intercept, y gonna be 0. So 0 equal to x minus 3, x minus 1, x plus 3. Okay, so we bring all this to the left-hand side. So we have 0 is equal to x minus 3. So solve this, you get x equal to 3 over 2. So actually you can have the point already. The point is 3, 2, 0. So your graph will obviously touch or cut this point. Okay? So for your y-intercept, your x will be 0. So y is equal to 2, 0 minus 3, 0 minus 1, 0 plus 3. So you get 1. So another point that your graph will be passing through is 0, 1. Okay? Okay, so how about C? So they want us to find the vertical asymptotes. Okay, wait, vertical asymptote. Okay, so I write here. So vertical asymptote. So remember, we need to find the value of A first. So we already have two values of A. Okay, so we have x equal to 1 and x equal -3. So we need to use limit to show that both of them are vertical asymptotes. So we are going to find limit x approaching 1 from left, limit x approaching 1 from right, limit x approaching -3 from left, and also limit x approaching -3 from right. Okay, so just write the function. Okay, so I'll just copy all of them because they are just the same. Okay, for this one, I don't want to show you the full calculation because it is just the same. Okay, so you can do by your own, okay, if you want. So I'll just give you your final answer. Plus infinity, negative infinity, negative infinity, plus infinity. Okay, so you already got the infinity as x approach the value 1 and -3. So you can make conclusion that vertical asymptotes are x equal to 1 and x equal to -3. Okay, settle. Okay, for part D, we need to find the limit x approaching infinity and x approaching -infinity, hence state the horizontal asymptote. Okay, so we are going to find limit x approaching positive infinity of our function. Oh wait, something wrong with my pen, guys. Oh no, please, not now. Okay. Okay, so this one is still also the same as what we do before. So it is infinity over infinity. So you have to divide each term with the highest power for denominator. Okay, so for this one, you have to expand first. Okay, you have to expand first. So it will become limit x approaching plus infinity to x minus 3. So you have to expand the denominator. It will become x squared plus 2x minus 3. Okay, so you will get infinity over infinity, right? So why do I expand? Because I want to find the highest power for denominator. So it is x squared. Okay, so again, just divide each term with x squared. So I'll just give you the final answer, which is 0. Okay, so just do the same when x approaching negative infinity. Just do the same for that. So you will also get 0 as your final answer. Okay, so remember, when you already have the constant when x approaching positive, negative, infinity, so this is your HA. Okay, so horizontal asymptote something wrong with my pen, guys. Asymptote is y equal to 0. Okay, settle A, B, C, D. Now for the last part, this is quite interesting and challenging a bit. Okay, why? Because we are going to sketch the graph. Okay, so we are going to sketch this graph. Okay, so don't worry. Don't worry, it is not that hard because we already find the limits and also the asymptotes. So it is actually helpful to draw our graph. Okay, alright, so how do we draw the graph using all the things that we already find? Okay, so look carefully. Okay, so first of all, what I'm gonna do is I will draw the asymptotes. Okay, so I'll draw the vertical asymptote first for our graph. So it is x equal to 1 somewhere here, -3 somewhere here. Okay, and then for our horizontal asymptote, it is y equal to 0. So y equal to 0 is here, which is the x-axis. Okay, and then I just write it like this, y equal to 0, and then x equal to 1, x equal to -3. So here is 0. Okay, so we already draw the vertical asymptote, and then the next one, remember, we have intercept. Okay, so the first one is 0, 1. Okay, 0, 1. So 0, 1 is here. And the second one is 3/2, 3/2 is here. Okay, so meaning that our graph will cut at this point. Okay, so now, okay, Okay, look carefully guys, look carefully. So we are going to plot some signs to know the shape of our graph. Okay, so for the vertical asymptote for 1. Okay, so first for x equal to 1, see here we have find x equal to 1. Okay, so from this it says that when x approaching 1 from negative, from left, so our y or our function will be positive infinity. So meaning it will be here on top. From left, the y will be positive infinity, a very big number. Okay, next one. 1 from right, it will be negative infinity, meaning 1 from right, your value of y will be a very small number, meaning here. So I'll put negative like that. Okay, next one. For x equal to negative 3 here, so when x approaching negative 3 from left, it will be negative infinity. Approaching negative infinity from left, your y gonna be negative infinity here, a very small number. And next one, negative 3 from right will be positive infinity. X approaching negative 3 from right, your y will be a very big number. So draw the sign close to your asymptotes. Okay, now for horizontal asymptote y equal to 0, it says that when x approaching positive infinity, this way, x approaching positive infinity, your y will be 0. Okay, your y will be 0. But notice here that approaching positive infinity of x, it can be here or here, right? So approaching 0, meaning that it can be either here or here. Okay, and the next one, approaching negative infinity, can be from the bottom or can be from the top. Approaching negative infinity, your y will also 0, meaning that the sign is here. Okay, so now we are going to connect the dots. Okay, so first of all, look at here. We have here, here, and here. So your graph obviously will be like this. Sorry. Like this, something like this. Okay, and it cannot touch the asymptotes. Okay, and then for this one, you have negative here and negative here. So you have either this one or this one. You have to connect the dots. But remember, you cannot touch this line, right? So obviously your graph will be like this. Okay, and the last one, it's either this one or this one. But see here, we have our x-intercept, so we need to cut the asymptotes. So it will be like this. Okay, so settle. So this is our graph. This is how we draw the graph using the information of limits, asymptotes, and intercept that we already found. Okay, now we are at the last example for 8.2. Okay, so we are given a function f(x), so they want us to state the domain of the f. Okay, so remember, domain is the value of x that make our function define. Okay, so you can see square root over here, so you will know that the square root, the function inside the square root cannot be negative. Okay, cannot be negative. So meaning that you know that x squared minus 9 will always be greater or equal to 0. However, this square root is at the bottom, is the denominator. So we know that denominator cannot be 0. So meaning that you cannot include the equal sign over here. Okay, so we just solve this one. This is inequality, quadratic inequality. So you just factor it out. We have x negative 3, x minus x plus 3 greater than 0. So this is quadratic inequalities. Remember, we learned inequalities in chapter 2. Okay, chapter 2. So we need to use table of sign. Okay, I just do it very quick. Okay, so we have two roots. The first one is x equal to 3. The second one is x equal to negative 3. So we start with negative infinity and then negative 3, negative 3, 3, 3 infinity. Okay, so for infinity, we'll always use open bracket. And then how do we decide whether we need to open or close the bracket? We look at the sign over here. So it has no equal sign, meaning that we need to open everything. Okay, so I just draw it very quick. Okay, ignore my ugly box, guys. I'm so sorry. So first we need to input the test value, and then the first factor, the second factor, and the final answer. Okay, so just put any test value that you want. Make sure it is in the range. Okay, so we get minus, minus, plus, 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 minus. So the final answer is be plus, minus, plus. Okay, so which sign are we going to choose? Look at again this one. It is greater, meaning that we need to choose the positive 1. Okay, so that's mean we already have the final answer for our domain, which is domain is from negative infinity until negative 3, union with 3 until infinity. Okay, alright, settle part A. Okay, now for part B. For part B, we are going to find the vertical asymptotes. Okay, so vertical asymptotes, so again, we already have the value of the constant, which is this one. Negative equal to 3 and x equal to negative 3. So you need to find limit x approaching 3 from left, x approaching 3 from right, and then x approaching negative 3 from left, limit x approaching negative 3 from right. Okay, so I just put the function. Okay, so again, I need you to do this by your own because we have no time. I don't want this video to be so long for you to watch. So you just do this by your own. Okay, so I give you the final answer. So 3 from left. 3 from left is undefined actually. Negative 3 from right is also undefined. And this is 3 from right is positive infinity. This one is negative infinity. Okay, why it is undefined? Actually, because when you substitute the value later, you will see that it will become 3 over square root of 0 that is negative. Okay, that's why it is undefined. Why it is undefined? Because remember, inside cert it cannot be negative, right? So that's why it is undefined. Okay, same case as this one. Alright, so notice that here for approaching 3 we have positive infinity and also undefined. Same as negative 3, we have 1 negative infinity and 1 undefined. So it doesn't matter, it's okay because remember, it is all. Okay, all. So meaning that we can still conclude that the vertical asymptotes are x equal to 3 and x equal to negative 3. Okay, doesn't matter. As long as one of them have the positive or negative infinity as final answer, then you can still make this conclusion. Okay? Okay, so now we are at part C. So part C, let me write it here. So part C, we are going to find the limit. Same as before, we are going to find the limit when x approaching positive infinity and x approaching negative infinity. Okay, so I just copy this again. Okay, for this part, remember, this is infinity over infinity and you have cert over here. So I already taught you last time in lecture that you need to factorize out first the x squared because it has square root over here. And remember this one. For square root x squared, it will be x is x approaching positive infinity and it will be negative x when x approaching negative infinity. Okay? So again, I need you to do this by your own. So you will get negative 1 over here and 1 over here. Okay, so notice that you have 2 different values, right? So it doesn't mind if you have 2 different values. If you approach positive and negative infinity, that means that you have 2 horizontal asymptotes. Okay? So horizontal asymptotes are y equal to 1 and y equal to negative 1. Okay? Alright. Okay, so now this is the important part. I want to draw the graph. Okay? So we are going to draw the graph. So we need to draw the y and x axis. Okay, so remember the step. We are going to draw the vertical and horizontal asymptote first. So first of all, let me draw the vertical asymptote. We have 2, 3 and negative 3. So somewhere here. And then for horizontal asymptote, we have y equal to 1 and y equal to negative 1. So something like this. Okay, now I'm going to label all the asymptotes. Okay, now let's draw the graph. Okay, so remember again, okay, we do it slowly, okay? So first for, sorry guys, it is 3 and negative 3, right? 3 and negative 3. Okay, so the first one, x approaching 3 from negative. 3 from negative, so meaning 3 from negative, approaching 3 from negative. It is undefined, meaning that it has no graph over here. Okay, no graph. And then x approaching 3 from right, your y will be positive infinity. So this is 3. X approaching, x equal to 3. From right, your y will be positive infinity, meaning that it is plus over here. Okay, next one. Negative 3 from left, it is negative infinity. Negative 3 from left, negative 3 from left, your y will be negative infinity, meaning it's here. And then next one, negative 3 from right, it is undefined. Negative 3 from right, it is undefined, meaning it has no graph. Okay, so next one, we are going to see the horizontal asymptotes. Okay, horizontal asymptotes. So when x approaching positive infinity, okay, your y will be 1, meaning that it will be really close to y equal to 1. So we have two arrow actually. We have can be either here or here. So we have to assign either this one or this one. Okay, and then when x approaching negative infinity, what will happen is your y will be approaching negative 1, meaning it can be here or can also be at the bottom. It can be here or here. Okay, alright, so now we are going to connect the dot. The first one, we have option either this one or this one. Obviously we cannot cross the y equal to 1, so it will be right like this. Sorry, it's a bit ugly, so just like this. And for this one, we have either this one or this one. So obviously again we cannot cross the y equal to negative 1, so it will be like this. Okay, alright, so we are done with our chapter 8.2.